Welcome to the Tech Mechanic. In this video, I'll show you the exact process architects use to convert business requirements into architecture diagrams. We'll use a real-world example of an Amazon-like shopping application and learn how requirements become services, APIs, databases, and ultimately a complete architecture design. Every software project begins with a business idea. The business doesn't ask for microservices, databases, or cloud platforms. Instead, they say something like, "We need an online shopping platform similar to Amazon." As architects, our first responsibility is to understand the business problem before thinking about technology. One of the biggest mistakes beginners make is choosing technology too early. Many people immediately start discussing Azure, AWS, Kubernetes, or databases. Experienced architects do the opposite. They first understand the requirements, because technology should always be selected to solve a business problem, not the other way around. Before drawing any architecture diagram, we need to understand what users want to do. In our shopping platform, users need to register, log in, search for products, add items to a cart, make payments, and track orders. These user activities become the foundation of our architecture decisions. Functional requirements describe what the system must do. These are the actual features users expect. Registration, login, product search, shopping carts, payments, and order tracking are all examples of functional requirements. Each of these features will eventually become one or more technical components in our architecture. Non-functional requirements are equally important. They define how well the system should perform. For example, supporting 1 million users, maintaining response times under 2 seconds, and achieving 99.9% availability. These requirements heavily influence our technology choices and architecture design. Now that we've gathered the requirements, the next step is understanding how users will actually interact with the system. This process is called mapping the user journey. Think like a customer visiting Amazon for the first time. The customer logs in, searches for a product, views details, adds the product to the cart, completes the checkout process, makes a payment, and then tracks the order. Every one of these actions requires the system to perform a specific function behind the scenes. By mapping the complete journey, architects gain a clear understanding of the business workflow. This becomes the foundation for identifying services, integrations, databases, and communication patterns later in the design process. This is one of the most important skills an architect learns. We take business activities and convert them into technical services. For example, when a customer logs in, that functionality belongs to a user service. Product searches belong to a product service. Cart management belongs to a cart service. Payment processing belongs to a payment service. Instead of building one giant application that does everything, we divide responsibilities into smaller focused components. This makes the system easier to maintain, easier to scale, and easier for teams to work on independently. Whenever you look at business requirements, start asking yourself, which service should own this capability? That's exactly how architects think. Once we've identified the services, we need to organize them properly. Modern systems are built using separation of concerns. Each service should have one primary responsibility. The user service manages users. The product service manages products. The order service manages orders. The payment service manages payments. This approach prevents systems from becoming tightly coupled and difficult to maintain. Imagine if every feature existed inside one massive application. A small change could impact unrelated functionality. By breaking the platform into independent services, organizations can develop, test, deploy, and scale each component independently. Many beginners assume architecture consists only of the software we build ourselves. In reality, most enterprise systems depend heavily on external services. Our shopping platform needs a payment gateway such as Stripe, Razorpay, or PayPal. It needs shipping providers to deliver products. It needs email or SMS providers to send notifications. These systems are not under our control, but they are critical to business operations. Architects must identify these dependencies early because they influence security, network design, reliability, and error handling strategies. Understanding external integrations is a key part of designing successful enterprise solutions. After identifying services, the next question becomes, how will these services communicate? In modern architectures, APIs provide the communication layer. When a customer searches for products, The application calls the Product Service API. When the customer checks out, the order service communicates with the payment service. APIs define clear contracts between systems and services. Good API design improves maintainability and makes it easier for teams to work independently. Architects spend significant time defining how information flows through the system because communication patterns directly impact performance and scalability. Choosing a database is not about selecting your favorite technology. It's about understanding the business requirements of the data. Different types of information have different needs. Order data requires strong consistency and transaction support. Product information requires flexibility and scalability. Frequently accessed data may need caching for better performance. This is why modern architectures often use multiple storage technologies. Architects evaluate data characteristics, access patterns, growth expectations, and business requirements before selecting storage solutions. Let's look specifically at order data. Imagine a customer purchases a product and the payment succeeds, but the order isn't recorded correctly. That creates a serious business problem. Orders require accuracy, consistency, and transactional guarantees. SQL databases excel in these scenarios because they enforce data integrity and support ACID transactions. Architects choose SQL databases when correctness is more important than flexibility. Understanding the nature of the data helps us select the right storage technology. Product catalogs have very different requirements compared to order data. Different products may have different attributes. A mobile phone has specifications such as RAM and storage, while a shirt has size and color. Trying to force all these variations into a rigid structure can become difficult. NoSQL databases provide flexibility and allow data models to evolve as business needs change. They also scale efficiently for very large product catalogs. This is why many e-commerce platforms use NoSQL solutions for managing product information. Security is one of the most critical responsibilities of a solution architect. Many projects treat security as something to add later, but experienced architects design security from the beginning. Modern systems typically use centralized identity providers, such as Microsoft Entra ID, Auth0, or Okta. Users authenticate with the identity provider and receive secure tokens that prove their identity. Services then validate these tokens before granting access. This approach improves security, simplifies user management, and ensures consistent authentication across the platform. Great architects don't only think about today's traffic, they think about tomorrow's growth. Imagine launching with 1,000 users and then suddenly growing to 1 million users. Can the system handle the increased demand? This is where scalability planning becomes important. Load balancers distribute traffic across multiple servers. Autoscaling adds resources when demand increases. Caching reduces repeated database queries. These techniques ensure the system continues performing well even as user traffic grows dramatically. At this stage, we can clearly see how architecture emerges from requirements. Requirements define what the business needs. User journeys reveal how customers interact with the system. Services implement business capabilities. APIs connect services. Databases store information. Security protects resources. Scalability ensures future growth. The architecture diagram is simply a visual representation of all these decisions. This is why architects never start with diagrams. They start with understanding the problem and gradually discover the solution. Let's examine the final high-level architecture. Users access the platform through web and mobile applications. Requests are routed through an API gateway, which acts as the entry point into the system. The gateway forwards requests to the appropriate services such as user service, product service, order service, and payment service. Each service performs its business logic and interacts with the required databases. External systems such as payment providers and shipping partners are integrated where needed. This layered approach creates a system that is secure, scalable, maintainable, and easier to understand. Every component exists because of a business requirement we identified earlier. This slide summarizes the mindset that separates architects from many technical professionals. Architects focus on the business first because technology exists to solve business problems. They focus on users because systems are built for people. They focus on requirements because requirements drive design decisions. Only after understanding these areas do they evaluate technology options. Azure, AWS, databases, frameworks, and programming languages are tools. Tools change over time, but the ability to understand problems and design effective solutions remains valuable throughout an architect's career. Developing this mindset is one of the most important steps in becoming a successful architect. Let's finish with a simple formula that every aspiring architect should remember. Requirements lead to user journeys. User journeys lead to services. Services communicate through APIs. APIs interact with databases. Together, these elements form the architecture diagram. Whenever you're asked to design a system, follow this sequence. Don't jump directly into drawing boxes or selecting technologies. Start with understanding the business. If you master this process, you'll be able to design systems that solve real-world problems and scale successfully as organizations grow. Thanks for watching The Tech Mechanic. In the next video, we'll take this knowledge further and design a complete Amazon-like architecture step by step. Don't forget to subscribe and continue your solution architecture journey.